All right, so let me just finish this quickly. But distance, it could go, this graph could look like this, side down, whatever, however crazy it is. It doesn't matter how crazy that graph looks, it would never, ever pass that horizontal axis, or the y-axis. Why? Because I can't have a negative distance. What do I mean by that? Distance, not displacement, distance. What do I mean by I can't have a negative distance? Distance is a scalar quantity, meaning that it can only have magnitude. It cannot have a direction, meaning that the sign, in a sense, would always be positive. I cannot have a negative sign there because there's no direction. It is distance. Distance is a scalar quantity, like I was talking about at the beginning of the class. Let's say I have a point A, I have a point B, A to B. Let's say the distance is 5 meters. Distance is a scalar quantity. I can only have a magnitude. In this case, it's 5. 5 meters is my distance. I cannot have a negative distance, right? Because it's a scalar quantity. I do not have direction. It's only 5 meters. That's why it would always be above the x-axis, so all the positive y values, right? That's why I said it's important, not just to memorize the terms, but to really understand them. That's different from displacement. Displacement, we know from our discussion at the beginning, displacement is a vector quantity, meaning that it has both magnitude and direction. So let me just say I'm starting at B and I want to go towards A. Yes, the distance between these 2 points, it's the 5 meters. But because I'm going to the left, we're considering that as the opposite direction. So I would put a negative sign here, just to indicate that the direction is opposite. So instead of going to the right from A to B, I'm going to the left, B to A. That's where that negative sign comes in. This is displacement. Remember, the definition of displacement is distance traveled in a specific direction. So distance traveled 5 meters in a specific direction to the left, which is indicated by my negative sign. That means that this graph, like I said, it would never cross the y-axis and go into negative times because that doesn't make sense. Time is a scalar quantity. You would never get a negative time. But for displacement, it can actually go below right here into negative values of y. So I could have like a -1, a -2. That negative sign just shows that it's in the opposite direction. So I can have a +1, +2, yeah. So my graph might look something like this. Come all the way down, go up. This just shows that it's moving in the opposite direction. So that's really the main difference between a distance time graph and a displacement time graph. Displacement can have negative values, negative y values, so it can cross this horizontal axis. But for distance time graphs, can't do that. It would always stay above the x-axis, so it only have positive y values. Do you understand that? Okay, that's great. Just keep that in mind. And before you go, I know it's over the time, I just want to show you one thing. Nothing, we're not learning anything. I just want to show you what the past papers look like. Say, so, like I said, back then, it wasn't mandatory to do kinematics questions. You actually had a choice between what do you call this? Statistics and kinematics. Well, statistics and probability and kinematics. Now you have to do the both of them, right? You have no choice. So that's very unfortunate for you, but you have to do it. So this is what I was talking about you would actually be required, well, it's a possibility. Like I said, in the 2021 paper, they didn't ask for a graph, but for all the other years, they did. There is a possibility. They give you information, and you actually have to do your own graph, draw your own graph. So this is a velocity time graph. We didn't do that yet, right? But we'll do that soon. And then from your graph, you have to be able to pull out data, all the information that you need in order to find what they want. So the total distance traveled by the car, the length of time. And this is actually where differentiation and integration comes in. But we're not there yet. We're dealing with this. Again, for this paper, where is it? All right, see, they actually give you the graph paper, well, the graph sheet. They give you the scale, and you are required to use the information that they gave you and plot your graph. See velocity time. Then from your graph, you need to determine different things. Let me just do one more because I think you get the idea. Like all of this is integration, but you can't see that yet. Hold on. All of this is integration and differentiation. You're not there yet. Let me just show you this one. Right. Sometimes they don't give you, no, they don't ask you to draw the graph. Oh, well, look at this. They didn't ask you to do it. Anyways, sometimes they actually gave you, what am I saying? Sometimes they give you the graph. So you're not required to draw it. They give you the graph. And from your knowledge, prior knowledge, you're supposed to be able to extract data from, well, information from this graph to get what they asked for. That's why it's important not only to memorize the terms and memorize the formulae, but actually understand what's going on and be able to read off graphs. Yes, so that requires practice, okay? Right. I mean, of course you got it.